Welcome back to module 11.4. In this lecture video, I'm going to show you how we can use a system of linear equation to solve cost and what we so-called amount problems. Okay, cost and amount. So these problems is where I need to use two different variables. Actually, makes it a little bit easier. So this is called the amount problem, where it says n has some dimes and quarters. So dime and quarters has a value to it. If she has 18 coin worth a total of $3.15, how many each type of coin does she have? So if I want to use two variable, I got to have two different equation or two things I can use to set it up. So in the first one is going to be the coins. Okay, the second thing is going to be about this money. So let's say, all right, how many each type of coin does she have? So the question is asking for how many coin. So dimes, let's call dimes to be x. Okay, so this variable x representing how many coins, how many dimes does she have? And let's call quarter y. And this is, so I got x number of dimes and I got y number of quarters in terms of coins. So if she has 18 coins, that means so many dimes plus so many quarters is equal to 18. All right. The next one going to be about money. So remember now, dimes is 10 cents. 10 cents in term of a dollar amount is 0.1. Why do I use dollar amount? Because my $3.15 is in dollar. So the value, the amount, dimes, each dime is $0.1 times X number of them that I have, plus, so this right here representing the money I have from the dimes, plus the money I have in terms of quarters. Quarters is valued at $0.25, right? 0.25 or 25 cents times y number of quarters. All right, so the money I have for the dimes plus the money I have for the quarters is equal to $3.15. Okay, that's how we write out the second equation. So let's use substitution methods. I'm going to solve for y again in the first equation. So move the x over, so that's y equal to 18 minus x. That's my first equation prime. So let's substitute my y, my 18 minus x into the second equation wherever I see a y, which is right there. So 0.1x still the same, plus 0.25 times the y, now replacing with 18 minus x equal to $3.15. So from here, it's just algebra here. Solving linear equation, 0.25 times 18 times negative x, 18 times 0.25, that'll be positive 4.5. 0.25 times negative x, negative 0.25x, set equal to $3.15. Combine like term, 0.1 minus 0.25. 0.1 minus 0.25. It's getting too late at night. I want to record this video, so I'm going to put it in the calculator. Negative 0.15. Negative 0.15x. All right, move my positive 4.5 to the other side, which become negative. So that will be 3.15 minus 4.5, which is negative 1.35. Divide both sides by negative 0.15. Let's see what I get. Divided by negative 0.15. My answer, 9. So that means I got 9 dimes. All right, 18 minus 9, that will give me my y, is also 9, right? So I got 9 dimes and what? 9 quarters. try another one. This one. I like a problem like this. The length of a rectangle is 5 meters less than 4 times the width. If the perimeter is 100 meters, find the length and the width. So this particular problem, I don't really have to use two variables. I'm just going to use one variable for this problem. The length of a rectangle is 5 meters less than 4 times the width. So I'm comparing between length and width. Since I'm comparing two items, the one that lists at the end of the translating sentence is always going to be x. So my length is 5 meters less than, means subtraction sign go in front what I just wrote. 4 got to go in front of that, times the width, which I already called it x. So my length is 4x minus 5. If the perimeter is 100 meters, so if you put the wording rectangle and perimeter together, that reminds you that actually trigger your mind to use the perimeter formula for rectangle, which is P equal to 2L plus 2W. So since my P is already 100, set equal to 2 times L. L is two terms representing one item, so I will put them in the parenthesis, plus 2W. W I already called it X. Since X is only representing for one item, one term for one item, I do not need a parenthesis. So a quick distribution, that will be AX minus 10 plus 2X. So AX plus 2X is 10X equal to negative 10, move over, become positive 10. That will give me 110. Divide both sides by 10. 110 divided by 10 got to be 11, right? Let's double check. 110 divided by 10. Yeah. So X representing the width, so the width got to be 11. So the length is 5 less than 4 times the width, so that's 4 times 11 minus 5. So that will be 44 minus 5. That will be 39. Okay, it's an arrow. So that will be 39 for length. Now, if you want to use two different variables, you can just call length and width as x and y. Okay, so one equation is still got to be using this formula. So that will be P equal to 2 times x plus 2 times y. The second equation got to be the translation part. Okay, to end up with two different equations. All right, this is one of my favorite questions about the admissions for games. Admission to a baseball game is $3 for general admission, $7 for the reserved seats. Okay, so if the receipts were $5,224 for a 1,280 paid admissions, how many each tickets were sold? So basically, again, I want to use two different variables. So I got to have two different equations. One equation got to be about this money thing. The second equation got to be about the total pay admissions. So let's say I have general admissions and the reserved seats. Alright, so admission means tickets, okay? Admission means tickets. So let's say I have X number of tickets for general admission, Y number of tickets for reserved. So since I have 1,280 paid tickets, that means my general tickets plus reserve tickets together got to equal to 1,280. So that's my first equation. All right, my second equation is the money I get from selling the two different types of tickets. So the bling bling, I'm gonna write it down here, okay, and erase it. So the money, the bling bling from the general admission plus the bling bling from the reserve seats together got to equal to this is 52.24. Okay, so how do I figure the money from the general admission? Well, I know every ticket for general admission is $3. So $3 a ticket times selling X number of them plus the money for the reserved. How much money did I get from the reserve? Well, each reserve seat is $7 a seat times Y number of those seats I'm selling, and put the money from the general admission plus the reserve is equal to 52.24. Okay, that's how we set up the second equation. So that's a cost and amount. All right, let's solve for I'm gonna solve for y again in the first equation. So let's move the x over. So that will be y equals 1280 minus x. Call the equation prime and sub this first equation prime into the second equation wherever I see a y. So that's 3x plus 7 times 1280 minus x equal to 52.24. So this is going to be negative again. All right, that's 3x plus 1280. By the way, I don't know if you noticed, if I was solve for x, I'd probably come up with positive right here. Okay. After I combine like term, I should be positive. But it does not really matter because as long as both sides are negative, my final answer will be positive, so I'm still good. 1280 times 7, 8960. 7 times negative x, negative 7x equal to 52.24. So 3x minus 7x is negative 4x. So I better have a negative on the other side. That's how I keep it. That's how I keep a track of I'm doing it right. 8960 move over, become negative. So that will be 5224 minus 8960. And that give me negative 3736. Divide both sides by negative 4. My answer, 934. So 934 representing X, which is representing general admission. So I sold 934 general admission tickets. So for the Y, that will simply be 1280 total sold minus a general admission 934. 1280 minus 934. 346. So I sold 346 for the reserve seats. All right, that's my answer for both of them. How many tickets were sold for each one? All right, same type of problem. This one is about Eleanor working her way through school. She worked 2 part-time jobs, very important, 2 part-time jobs for a total of 34 hours a week. Job A, so I got job A. Job A pays $6.40 per hour. Job B is paying $7.30 per hour. How many hours did she work at each job? So the question is asking for hours at each job. So my variable got to representing hours at each job. That she will make $234. Okay, so let's just say job A, she worked X hours. Job B, she worked Y hours. So the first equation, got to have 2 different equations, okay? One of them got to be about this total of 34 hours. The second equation got to be about the money she made from the 2 jobs, working those X and Y hours. So total 2 jobs working together is 34 hours. So that would be X plus Y equal to 34 hours. All right. So how does she make this $234? So job A pays $6.40, and she worked there for X number of hours. So we normally times by X. Plus job B pays $7.30 for an hour, and she worked Y hours, right? So the money she make from working those hours at job A, those money plus the money she make, 730 an hour times Y number of hours, that will give me the money she make from job B. And the total of the two together is $234.70. That's my second equation. So quickly, let me solve this real quick. Solve for x, this time in number 1. So I get y over, so that's x equals 34 minus y, first equation prime. Let's substitute my first equation prime into the second equation for x. Okay, so normally 6.4 times x, now it will be 6.4 times, substitute x for 34 minus y, plus 7.3y equal to 234.7. All right, let's do a quick distribution here. 6.4 times 34, that'll be 217.6 minus 6.4y plus 7.3y equal to 234.7. All right, so want to combine like terms here. 7.3y minus 6.4y, 0.9y equals, so that's a positive, so the other side better be positive. Move the 217.6 to the other side, become negative. So that's 234.7 minus 217.6. That's 17.1. Is that right? Yep, divide both sides by 0.9. My answer, 19 hours. So she worked at job B. Y is job B, 19 hours. So job A is 34 minus 19 hours, right? Because together is 34. The two jobs together is 34. So 34 minus 19. Voila, she worked job A, 15 hours. All right, that's the answer for both. So just a quick few examples regarding to how we can use system of linear equation to solve what we so-called the cost and the amount problems. All right, that will conclude this lecture video. Thank you for watching.